Welcome to my student. Now today's lectures we are going to discuss new chapters natural products. In the chapters we have going to learn we are going to learn the citral. It is a natural products we can synthesize by using various techniques. Firstly, we can determine the structures of citrals. Citral are very important members of acyclic monoterpenoids, which is present in the lemongrass oil about 70 to 80%. But lemongrass oil, which is treated with excess of saturated solution of sodium bisulfate, then this citral form crystalline bisulfate derivatives, right? Though the citral can extracted with ether and then this ether can evaporate. Finally, they can purify by distillation in vacuum. The citral is obtained as a colorless liquid having the smell of lemon and which is optically inactive. Citral is an acyclic monoterpene having the formula which is found to be C10H16O. C10H16O. Some reactions can done on these citrals as like the citral can add bromine to give a crystalline tetrabromo derivatives. It means that is present carbon-carbon double bond. Such a type of reaction can be done at the practical as like the saturation unsaturation test. Two tests are used as like the Bayer test, that is the Kaminoff test, and other tests are the bromine test. So in this citral add bromine to give tetrabromo derivatives. It means it shows carbon-carbon double bond is present. Next, citral forms the oxime derivatives with the hydroxyl amine and phenylhydrazone to use with phenylhydrazine. It means that citral forms oxime derivatives with hydroxylamine hydrochloride or phenylhydrazine to use phenylhydrazone derivatives. As like this is a phenylhydrazine can react with this carbonyl compound to get phenylhydrazone derivatives. It form the phenylhydrazone derivatives. It means shows it contains the carbonyl group, right? If it is present carbonyl group, therefore shows to form such molecules. If it is absent, such molecules cannot form. But still, in citral forms such a molecule, that is phenylhydrazone derivatives, and therefore we consider that the citral will be present. The carbonyl group are here. Similarly, hydroxylamine, we can add those molecules to give oxime derivatives, and therefore it must contain carbonyl group present in the citral. When the citral is reduced by using sodium amalgam, they gives primary alcohol as like the geraniol, and such on oxidation it gives geranic acids, but without loss of any carbon atom, and therefore citral must contain aldehyde group. Another test can also done. You know that it is a very famous test, failing solution test. So such a test can be used to detect the citral. It must contain aldehyde group. Failing solution test can be used to detect aldehyde group, and therefore failing solutions in citral shows present this test. Next, the molecular formula of saturated hydrocarbons is C10H22, which is corresponds to CnH2n plus 2, and therefore those formula it shows it must contain a cyclic monoterpenoid. On heating up citral with the potassium bisulfate, and it gives paracymene. Write this. So those carbon skeleton will be present, or it is possible such a types of skeleton will be present, but such citral can be heating with potassium bisulfate, and it gives the paracymene. Hence, to formation of paracymene, it means that it contains open chain carbon skeleton can be present or can be assigned are here. The formation of paracymene, it shows contains this methyl and isopropyl group is in same position, right? This is isopropyl group and this is a methyl group. It is present in the same position. It means para positions. So paracymene is formed. Next, some reactions also can be done on citral. It must contains the methyl and isopropyl group can be confirmed by using this reaction. The first reactions, we add citral. The citral add 2 moles of sodium bisulfate, right? Citral add 2 moles of sodium bisulfate. This is sodium bisulfate. 2 moles add. Therefore, the characteristics of alpha beta unsaturated aldehyde. One of sodium bisulfate is added to carbonyl carbon and other sodium sulfate is added to this carbon carbon double. So it must contains one of this carbonyl group and one is carbon carbon double bonds which are the conjugated with this carbonyl carbon. Such types of intermediate will be formed. Second reaction can be done on citral as like the aqueous alkali can add to hydrolyze and produce acetaldehyde. Acetaldehyde and ketones called methyl heptanone. It is characteristics of alpha beta unsaturated aldehyde. It means the citrals we can add alkali like the potassium carbonate in water and to form this aldehyde or the ketones, right? This is aldehyde or the ketones. It means that it is must contain alpha beta unsaturated aldehyde. It means this is alpha carbon, this is a beta carbon. So alpha and beta unsaturated aldehyde, it must be present in the citral compound. Next reaction, so the citrals which on hydrolysis with water and produce methyl heptanone and the acetaldehyde, methyl heptanone. Finally, those citrals we can pass UV spectrum and they will show the value about 235. So those values of 235 confirm that citral is alpha beta unsaturated aldehyde. Next point, we are prepared methyl heptanone. You know that methyl heptanone, the molecular formula is C10H14. Oh, so this methyl heptanone can be formed or some reactions can be done on this methyl heptanone. So methyl heptanone, we add 1 molecules of bromine. It means it contains the double bond is present in methyl heptanone. Another reaction, methyl heptanone gives the oxime derivatives, right? Methyl heptanone gives oxime derivatives with hydroxylamine hydrochloride. and therefore methyl heptanone it shows it is present carbonyl group. जर कार्बोनिल ग्रुप जर असेल तरच ऑक्झाईन ही रिॲक्शन होते आणि म्हणून आपण इथं ऑक्झाईन तयार होतोय याच्यावरून सांगतो की याच्यामध्ये कार्बोनिल ग्रुप प्रेझेंट आहे. राईट. नेक्स्ट, इट गिव्स हॅलोफॉर्म रिॲक्शन विथ सोडियम हायपोब्रोमाइड. राईट. मिथिल हेप्टॅनोन रिॲक्शन कोणती होते? हॅलोफॉर्म रिॲक्शन होते. यू नो दॅट हॅलोफॉर्म रिॲक्शन? Halophane reactions are mostly to show the methyl keto group. So such a group which is present. असा ग्रुप जर असेल तरच हॅलोफॉर्म रिॲक्शन होते. परंतु अशी हॅलोफॉर्म रिॲक्शन मिथिल हेप्टॅनोन मध्ये होते आणि म्हणूनच अशा टाईपचा ग्रुप त्याच्यामध्ये प्रेझेंट असेल. नंतरची रिॲक्शन आहे ऑन ऑक्सिडेशन विथ पोटॅशियम परमॅंगनेट इट गिव्स ऍसिटोन अँड लॅहुलिक ऍसिड. याच्यामध्ये आपण काय केलंय, मिथिल हेप्टॅनोन आहे याच्याबरोबर अल्कलाइन केमिनोफोरची जर रिॲक्शन केले तर दोन मॉलिक्यूल आपल्याला मिळतात. एक म्हणजे ऍसिटोन आणि दुसरा आहे लॅहुलिक ऍसिड. आणि ह्या दोन मॉलिक्यूल्स आपल्याला मिळतात. याच्यावरून आपल्याला सांगायला येतं की सच मॉलिक्यूल्स विच शोज ऍसिटिल प्रोपॅनोइक ऍसिड, लॅहुलिक ऍसिड, ऍसिटिल प्रोपॅनोइक ऍसिड. So all these assumptions or all these reactions, we confirm that or by experimental facts, the structures of methyl heptanone, it must be this like, right? For those reactions, we are possible the structures of methyl heptanone is this like, and therefore next, the number of reactions which are obtained or which are occur on the citral, these reaction can be done on the citral. Reaction can be done on methyl heptanone, and these reaction also done on the citral as like the firstly oxidation with KMnO4 and followed by chromic acid on the citral, it gives acetone and lactic acid plus oxalic acid in the सिट्रल. म्हणजेच आपण सिट्रल वर जर पोटॅशियम परमॅंगनेटची रिॲक्शन केली अँड क्रोमिक ऍसिड बरोबर तर आपल्याला तीन मॉलिक्युल्स मिळतात. त्याच्यामध्ये ऍसिटोनिक मिळतो आणि लॅहुलिक ऍसिड एक मिळतं. मिथिल हेप्टिनोन मध्ये आपण जर रिॲक्शन केली तर काय मिळत होतं आपल्याला? ऍसिटोन मिळत होतं आणि लॅहुलिक ऍसिड मिळत होतं. परंतु सिट्रल मध्ये आपल्याला एक एक्स्ट्रा मॉलिक्युल्स मिळत होतो म्हणजे ऑक्झॅलिक ऍसिड. अँड देअरफॉर नेक्स्ट, सिट्रल ऍड्स 2 मॉलिक्युल्स ऑफ ओझोन. सिट्रल मध्ये 2 मॉलिक्युल्स ओझोनचे ऍड होतात आणि त्याच्यानंतर आपण जर हायड्रॉलिसिस केलं त्या ओझोनाइडचं तर काय मिळतं आपल्याला? एक मिळतो ऍसिटोन, दुसरं मिळतं लॅव्हल्डिहाइड आणि तिसरं मिळतं ग्लायझॉल. राईट. म्हणजे सिट्रल ऑन ऑक्सिडेशन विथ द 2 मॉलिक्युल्स ऑफ ओझोन with H2O2 hydrogen peroxide, it gives 3 molecules. One is acetone, second is lactaldehyde, and third is a glycol. अशाच प्रकारे the formation of acetone, it shows isopropyl group. Okay? One this methyl, one this methyl. 2 methyl is there. हा एक मिथिल आणि हा एक मिथिल. म्हणजे ऍसिटोन तयार झालंय त्याच्या अर्थ याच्यामध्ये एक आयसोप्रोपिल ग्रुप आहे. बरोबर. हा एक आणि दोन हे दोन मिथिल ग्रुप. So isopropyl group is present on the citral, and also by using confirm the band 550 to 890%. आणि ह्या IR व्हॅल्यू वरनं आपण कन्फर्म केलं की ह्याच्यामध्ये कन्फर्म असा ग्रुप आहे, आयसोप्रोपिल ग्रुप प्रेझेंट आहे. नेक्स्ट, citral is an alpha beta unsaturated aldehyde, right? This is a alpha and this is a beta. So citral is an alpha beta unsaturated aldehyde containing the 2 carbon atoms more than methyl heptanone, right? आपल्याला मिथिल हेप्टॅनोन मध्ये किती मॉलिक्युल्स मिळाले होते? 2 मिळाले. कोणते 2 होते? एक होता ऍसिटोन, दुसरा होता की लॅहुलिक ऍसिड किंवा लॅव्हल्डिहाइड. बरोबर. परंतु एक एक्स्ट्रा मॉलिक्युल्स आपल्याला याच्यामध्ये मिळतोय, तो म्हणजे कोणता? ऑक्झॅलिक ऍसिड किंवा ग्लायझॉल. आणि याच्यावरून आपल्याला सांगता येतं की Citral is alpha beta unsaturated containing 2 carbon atoms more than methylheptanone. Methylheptanone पेक्षा 2 कार्बन कशामध्ये जास्त आहेत? Citral मध्ये. Therefore, the structures of citral is as like this, right? This is such a type of structure may be present on this the lemon juice or lemon oil, lemon grass oil. आता आपल्याला काय करायचं, कन्फर्म करायचं खरोखर अशा टाईपचं स्ट्रक्चर त्याच्यामध्ये आहे का. सो कन्सिडरिंग द स्ट्रक्चर्स ऑफ सिट्रल ऑफ डिफरंट रिॲक्शन कन्फर्म बाय द सिंथेसिस. आपल्याला ते सिट्रल सिंथेसाइज करायचंय, खरोखर तसं सिंथेसिस होतंय का. तर काय केलंय बघा, अगोदर त्यांनी सिट्रलचं रिॲक्शन केलं सिट्रल बरोबर. सिट्रल can treat with the potassium carbonate and water to give 1 molecules of methylheptanone and plus this is glycol. बरोबर आहे. Citrals also treat with alkaline KMnO4 and chromic acid. It gives 3 molecules. Which one? One of the acetone, second levullic acid and third one is oxalic acid. Right. नंतर काय केलं आपण, Citral can treat with the ozone. The 2 molecules of ozone can treat and to give such a types of ozonide. आपल्याला माहिती की ओझोनचा रोल काय आहे, कार्बन कार्बन डबल बॉन्डचं ब्रेक करतो. इथला एक ब्रेक होईल आणि इथला एक ब्रेक होईल. इथला ब्रेक झाला तर काय मिळेल, 1 मॉलिक्यूल ॲसिटोन. इथला जर ब्रेक झाला तर काय मिळणार, ग्लायक्झॉल आणि 1 मॉलिक्यूल्स ऑफ लॅव्हुलाल्डिहाइड. बरोबर, असं पाहिजे. म्हणजे इथं 2 मॉलिक्युल्स रिॲक्ट होतात, म्हणजेच कार्बन कार्बन डबल बॉन्ड किती आहेत, 2 आहेत. राईट, इथला एक कार्बन कार्बन डबल बॉन्ड, इथला एक कार्बन कार्बन डबल बॉन्ड, म्हणून 2 molecules of the ozone react and to form the ozonide. And these ozonides which can hydrolysis with water in zinc to give 3 molecules. Which one? One is a acetone, second is a lactaldehyde and third one is a glycol. Right. Now we have synthesis the citral from methylheptanone. आपल्याला माहिती आहे की मिथिलहेप्टेनॉन सारखं स्ट्रक्चर सिट्रल मध्ये आपल्याला दिसलं होतं. तर आपण बघायचं की मिथिलहेप्टेनॉन बरोबर सिट्रल्स आपल्याला तयार करता येते का. सो दिस इज अ सिंथेसिस ऑफ मिथिलहेप्टेनॉन. फर्स्टली वी आर सिंथेसिस मिथिलहेप्टेनॉन. फर्स्टली दिस 3-methyl butane diol. 3-methyl butyl diol can treat with anhydrous zinc chloride. Then what happens? After remove the water molecules and to get isoheptene. This is a 1, 2, 3, 4 and 5 isoprene unit. काय तयार झालेलं आहे, आयसोप्रीन युनिट आपल्याला मिळालेलं आहे, म्हणजेच आयसोप्रीनाइड ग्रुप्स. And then these groups can treat with the bromine and to get dibromo derivatives, which is this is a carbon carbon double bonds are converted to dibromo derivative plus sodium acetyl acetone will be forms. Then after treat with the sodium acetyl acetone, then what happens, this is replaced, okay, this is replaced to form this, right, bromine. This bromine can replace by such a group, that is this negative charge, that is a carbanion, which are more stable, is attack on this carbon and replace this bromine molecule, that is a HBr, NABr, right, HBr. So this is attached to this carbon and this bromine will replace as a HBr, right. Then after formation of those molecules which can treat with the NaOH and to get the molecules is methylheptanone, right, the methylheptanone. After formation of this methylheptanone, now we are prepared to synthesize the citral by first method. In the first method, what happens? This methyl heptanon, right? This is a methyl heptanon we are prepared by last slides. This is last slides. Sorry. This is methyl heptanon. We are prepared from the 3-methyl butane 1-ol. Using these techniques or using this chemical method, we are prepared methyl heptanon. And then these methyl heptanons are used to prepare citral. So how will you form the citral? This is the first method. This is the first method. In the first method, what happens? The methyl heptanon is subject to reformate reaction with iodoacetic ester, right? This is iodoacetic ester. Iodoacetic ester. Then what happens? This iodoacetic esters and zinc dust, the product is hydrolyzed and to get the gyrianic acid, right? This is a gyrianic acid. And finally, the calcium salt is distilled with calcium formate to get the citral, right? This is a process. Firstly, this is a methyl heptanon treated with, this is a iodo acid acetic ester, iodoacetic ester. Then what happens? This is from these intermediates. It means CH2 minus is attack on this carbonyl carbon and to form negative charge on oxygens. So O minus convert to OH, right? This OH, this is CH2, CO2, ET. And then after hydrolysis or replace the water molecules, that is these hydrogens and one OH to replace water molecules, form the carbon-carbon double bond are here. And then after calcium hydroxide are treated to form this ester convert to acid and acid are convert to salt, that is a calcium salt of this citral, right? You know that ester hydrolysis gives the acid, and acid can treat with the strong alkali as like NaOH to form sodium acetate, to form calcium hydroxide strong alkali, so calcium acetate as like this. So calcium salt of this citral will be formed, and then after distilled with this calcium formate to use the citral, right? To use the citral. This is a first method we can synthesize by using the heptanone as a citral. In the second method, we are used to prepare these citrals like in methyl heptanone is condensed with Grignard reagents as like this is a Grignard. These Grignard reagents ethoxyacetylene magnesium bromide, ethoxyacetylene magnesium bromide. This is carries negative charge, right? So this negative charge attack on this carbonyl carbon to form negative charge on oxygens. O minus convert to OH as like this. O minus convert to OH. And this chain is attached to this carbon like this. C triple bond this. And then after formation of such intermediate can treat with H2 palladium in presence of PSO4. What is the role of H2 palladium? It reduces the carbon-carbon triple bond to carbon-carbon double bond, right? So this is a reactions in presence of H2 palladium in presence of BaSO4. It reduces carbon-carbon triple bond to carbon-carbon double bond are here. And then after formation of those products can it is interchange the group as like this carbon-carbon double bonds transfer are here to form the carbon-carbon double bond between these two carbons, and this OH will be replaced and is going to R here, right? This is OH is going to R here. R called as a allylic rearrangement. This is called as a allylic rearrangement. You know the rearrangement? Rearrangements are only group transfer can take place from one position to other position, right? This OH it transfer from this to this carbon, and this carbon double bond transfer to here. So carbon carbon double bonds are here, OH is there. And then after this OH to form carbon carbon double bond is here, and loss of ethoxide, right? Ethoxide, hydrogens, and this ethoxide. So from the double bond is here, and loss of ethoxide as a ethyl alcohol, and to form citral. So this is a second method we are used to prepare the citral from methyl heptanol. It's condensed with the acetylene, magnesium, bromide, and partial reduction, then acidification to use the